All right, so now that we've looked at kind of the definition and some explanation for the difference between rational and irrational, I've got some examples here, and we just have to determine if it's rational or irrational. So kind of like a true false here, we're just going to write out the word rational and irrational. And please do try to write out the whole word. That way, if it's an R or I and I can't tell, I'll have to mark it wrong, and I hate doing that. So just the whole word so we know for certain. So, some of these can be kind of tricky. I think people overthink them a little bit. For these square roots, just type in your calculator. If it comes out to be a perfect square, so maybe if that was the square root of 36, I would get out the answer 6. So if it comes out to be a perfect square, a nice whole number, then it is rational. If we type this one in, we get these crazy decimals. So it is irrational. For B here, anytime we've got just a nice fraction like this, type that in your calculator. I'm typing square roots in my calculator. If you type this in, it's going to look like a decimal that looks wonky and you're like, oh, it's irrational. Remember, the definition of rational means it's written as a fraction. This is written as a fraction, so it is rational. Similarly, C is kind of tricky. People look at that and they think, oh, it's pi. That's not pi. Pi is the symbol pi, or it's a decimal that keeps going on and on and on forever, which means it would have the ellipse at the end. This decimal stops. It's just done. So any decimal that just stops every single time is rational. That's true no matter what thing I give you. 0.5 stops, it's rational. That's 1/2. This number could be written as a fraction, is 314 over 100. We don't have to know that, but any decimal that stops is rational because that could be written as a fraction. D here is also rational because it has that repeating pattern. This is 0.45454545. So it's just 45 over and over and over again. So that makes it rational. E, this one might be a little bit trickier to see. It's very similar to D, but the 4, 5 is different each time. So I've got these 4 5s, but I have all these extra 5s too. So I could not write it with the repeated, the line underneath it. It's not the same thing over and over again. It's not that copy paste. I think about rational numbers, the ones underneath the line. If you just hit the copy button on everything underlined and you just paste, you could get it out. This you could not. You would have to add a whole bunch of extra 5s. So that makes this one irrational. F here is something where I could just copy and paste. Here's 7, 8, 9. There's 7, 8, 9. There's 7, 8, 9. I could write this with the repeated. So that makes this one rational. This last guy, we're going to get to see some more examples of it in just a second when we practice some square roots. But before I can just do this one, I probably need to reduce it down. So I'm going to write this, and I've got the rules written up on the next page. We'll see some more practice. I can write it just as one square root. This is the quotient rule. We're going to see, I've got it typed up right on the next page so that you'll have it. So I can take those two separate square roots and just combine them into one square root. 20 over 5 is 4. 20 divided by 5 is 4. And now it's going to work similar to A up at the top. I can type that in, or maybe I know what the square root of 4 is. It is 2. So anytime I get a nice whole number, a perfect square answer, then my answer is going to be rational. And we'll get some more practice with those square roots, like I said, in just a second. So let's look at another kind of wonky problem before we head to the square roots. So in this example here, I've got two irrational numbers. Both of these guys are irrational numbers, and that's actually part B. I've got the sum of two irrational numbers. They're irrational because if I just copied and pasted 2, 7, I would have all the extra things. And the same thing with 6, 1. If I just copied and pasted it, I would have all those extra ones there. So that makes these two irrational numbers. Now these, I chose really specific numbers here. And if we add these up, we can add the columns up. 2 plus 6 is 8, but 7 plus 1 is also 8. In fact, all of these, every column that I add, I'm sure I'm not doing it justice, making sure they all line up. Every single time I get 8. They're all just 8. This is something that can be repeated. That is 0.8 repeating. We can also think about it as a fraction. It's 8/9. Anything that can use that repeated means that can be written as a fraction. And so that means that my answer is a rational number. So these irrational and rationals are super intertwined all together there. Just because I start with two irrational numbers, there are special times when I can come up with rational like this. Now, there are tons of times you might be thinking that doesn't always work. You're totally right. It doesn't always work. But there are times, that's where we wrote may, give us the answer that is rational on there.